Hello. In this video, we shall discuss UI Automation Tools and Library. UI automation technologies enable software to mimic human interaction with graphical user interfaces, clicking, typing, and navigating, to automate repetitive tasks or testing. The tools and library discussed here are based on Microsoft UI automation technology. Microsoft UI Automation, UIA, is a powerful, modern accessibility framework for Windows that enables applications to expose UI element information to assistive technologies, screen readers, and automated testing tools. It serves as a successor to Microsoft Active Accessibility, MSAA, providing improved, structured, and reliable control interaction across WPF, WinForms, and UWP apps. Key aspects of Microsoft UIA. Accessibility and automation. UIA allows developers to make applications accessible to users with disabilities and supports automated testing and robotic process automation (RPA) tools. Tree structure. UIA represents UI elements as an automation element tree, with the desktop as the root, allowing for easy navigation and identification of controls, buttons, menus, etc. Providers and clients. The architecture consists of providers, which expose control info, and clients, which consume that info. Control patterns. Instead of just querying a button's type, UIA uses control patterns to interact with functionality, such as invoke pattern for clicking a button or value pattern for editing text. The user interface automation libraries consists of two components: Control DB tool and UIA driver library. The next slides discusses this in detail. Control DB tool is an easy-to-use application to capture UI elements from the GUI of an application for UI automation. The captured UI elements can be saved to a file in different formats for reuse. The code definitions can be generated in different languages. The snapshots of UI elements bitmap can also be captured and saved. In addition, user actions can also be recorded and code can be generated which can be replayed. UIA driver is a managed class library that provides programmatic UI automation capabilities on UI elements previously captured by Control DB tool. These capabilities are provided by control patterns, where states of the UI elements can be queried and UI actions can be performed. UIA driver implements 16 control patterns, out of which 13 are implemented by the UIA framework, and remainder are custom patterns provided by the UIA driver. These control patterns perform a range of activities depending on the type of the UI element. For example, clicking a button, checking a checkbox, selecting a combo box item, etc. UIA driver supports both User Interface Automation (UIA) and MSAA, Microsoft Accessibility API architectures. UIA driver also provides APIs for synchronization and an iDispatch interface for scripting clients. Process. The process involves 3 steps. 1. Launch Control DB tool and capture GUI controls on which automation is performed. These can be buttons, radio buttons, checkboxes, combo boxes, etc. 2. Generate automation code using UIA driver library. 3. Compile and build executable and playback. The first 2 steps can be done manually or by using recording feature. The next slide will discuss this in details. This slide discusses details of how the user actions on the test application can be recorded, and code can be automatically generated for the playback. It involves 3 steps. Step 1. Record user actions on the test application. Step 2. Manually map events for unmapped user actions. Step 3. Generate code for the selected programming language for the playback. The next slides explain this in detail. Recording user actions. First, launch Control DB tool, then the test application. On Control DB tool, click Record button to start recording user actions on the test application. Once done, on Control DB tool, click Record button to stop recording user actions. Later, the user will be prompted to save the recording. This is demonstrated in the video in the next slide. Map events. After the recording is complete, the Control-DB tool automatically maps user actions against the generated events, such as mouse button click or key press. Each event is internally bound to a control pattern. For example, button click is bound to invoke pattern. And one-on-one mapping is done for each user action on the GUI control, triggering the event. However, there would be some unmapped user actions with unmapped events. A dialog containing all unmapped events and all the unmapped user actions is presented. The user can manually map the unmapped user action with an unmapped user event. Later, the changes are saved. The right side of the Control-DB tool will be populated with GUI objects, such as buttons upon which user actions were performed. The next step is to save these GUI objects and generate code. This is demonstrated in the video in the next slide. Generate code. Code generation is triggered by clicking Generate Code button. This will load a dialog containing all the GUI objects on which user actions were performed. The user will manually select the GUI objects for which code needs to be generated in the selected programming language. The code contains two parts. First, a list of all the GUI objects as JSON. Second, the actual code that drives the automation. For each GUI object, the driver code contains calling the appropriate methods in the control pattern for the mapped event. The video in the next screen demonstrates it. This dump of the source code gives more details. The first section contains details of each GUI object in JSON. The second section contains driver code. Here, appropriate functions in the control patterns are called on the GUI objects. This slide discusses details of manually selecting the GUI objects such as button, checkboxes, and generate code containing only definitions of the GUI objects without driver code. It involves two steps. Step 1. Select GUI objects on the test application. Step 2. Generate code for the selected programming language. The next slides explain this in detail. Select GUI objects on the test application. First, launch Control-DB tool, then the test application. On the test application, select the GUI object and press F12 key. On the Control-DB tool, this will load the GUI objects tree on the left-hand side and selected object the right-hand side. More objects can be added from the GUI objects tree or pressing F12 on the control. Later, click Generate Code button. The user will be prompted to save the recording. The video in the next screen demonstrates it. Generate code. Code generation is triggered by clicking Generate Code button. This will load a dialog containing all the GUI objects that were selected in the previous step. The user will manually select the GUI objects for which code needs to be generated in the selected programming language. As noted earlier, the code contains only a list of all the GUI objects as JSON. The video in the next screen demonstrates it. This dump of the source code gives more information. It contains details of each GUI object in JSON. Compile, build the executable, and playback. In this step, the generated code may be modified to include pre- and post actions. Later, the source file is compiled with the assemblies of the UIA driver and other required assemblies. After the compilation, an executable is generated. The video in the next screen demonstrates it. Later, it can be executed to mimic the captured user actions. This is shown in the next slides. Demo. 2 scenarios. Record arithmetic operations on the calc application without coding. Capture a complex multi-part automation with scrolling using customized code. In this demo, multiplication operations are performed on the calc application. The automation is recorded as discussed in the automatic code generation slide. The source code is modified to launch calc application. The source is compiled with UIA driver assemblies to generate runcalc.exe. This is run to replay. This is shown in the video in the next slide. In this demo, a series of automations are performed to capture images in the visual tree and later stitch them back together. As some of the individual images are quite big, they are captured in batches into individual parts after scrolling. The code is customized-based manual code generation discussed earlier. The source is compiled with UIA driver assemblies to generate an executable. This is run to replay. This is shown in the video in the next slide. Post-processing. Later, the captured images are processed to put them into 2 separate bins, as question and answer as shown. The first section contains raw captured images from the automation. The second section shows 2 images, a question and an answer, containing raw images that are stitched accordingly. Thanks for your time. For any suggestions or questions, send an email to the email ID shown.